Hi everyone. Having talked about radioactivity, I wanted to talk a little bit about radiation sickness. I'm by no means an expert on the biology here, but I wanted to talk a little bit about how the physics is used to calculate some of these things. So I mentioned the fact that there are three basic types of radiation: alpha, beta, gamma. These actually are ordered in the ease with which we can shield ourselves from them. So alpha radiation is actually quite easy to block yourself from. Just a piece of paper will block those helium nuclei from, penetrating the object. Beta radiation, somewhat on the middle, usually a few millimeters of aluminum is necessary. Gamma radiation is the thing that requires lead. So usually you've got a few inches of lead as the thing that can protect you from this gamma radiation. Remember, the gamma radiation is not a particle; it's just a photon of electromagnetic energy, but yet it's very problematic. And the reason it's problematic is that it's of a high enough energy level that it actually can ionize the atoms inside the body, or ionize any kind of atom. Remember, the ionization energy is on the order of a few electron volts, and so that's the amount of energy inside these different types of radiation, which is what makes them so dangerous. We call these types of radiation ionizing radiation to distinguish it from other forms of radiation, like the microwave oven, for example, is also radiating electromagnetic energy, but that energy level is not the right energy to actually interact with the atoms and basically start to destroy some of the chemistry going on there. But these alpha, beta, gamma type of radiation are. And so that's kind of how radiation sickness occurs, is that these different radiation levels, these different radiation particles actually interact with the chemistry of the body and destroy some of the molecules. Now, the amount of radiation that is required to actually produce sickness depends on several factors. Obviously it depends on the amount of energy that's being absorbed. It also depends on the mass of the thing that's doing the absorbing. It also depends on the type of radiation. Alpha radiation, although very easily to block, is highly damaging because it has that +2 charge on it. The beta radiation, which has a negative charge, also is very damaging. The gamma radiation is less so, even though it's the more the hardest one of all to block. So, it all kind of varies, and then of course it depends on the biological subject. So if we're talking about humans, all this is combined together in something called the relative biological effectiveness, the RBE. And basically you use that factor to calculate something called the sievert. A more common term is the rad, R-A-D, but the SI unit that corresponds to that is the sievert, and so that's what we use basically to measure the biological impact of various radiation sources. And so on this chart here, this shows, basically, how many of these sieverts of radiation dose, how much damage they do. So, there's a federal limit for people who work in nuclear industries of 50 millisieverts per year. That's the maximum radiation exposure one can have, annually. About 200, it starts to affect your white blood cell count. Your white blood cells are what control your immune system. And so once that, it starts attacking your white blood cells, you start to feel it starts to affect your health. About 500, you actually start to feel sick. About 1,000 millisieverts, one full sievert, it starts to become fatal 10% of the time, and it just increases obviously as you go on. About 6,000 millisieverts pretty much is the maximum the human body can withstand, and so you get about 100% fatal rate. So the average American's exposed about 6.2 millisieverts per year. So just by the fact that we exist and just live in this country, we've got about 6.2, which is very far away from any of these numbers. So we're still pretty safe in that regard. This pie chart actually shows a distribution of the different sources of radiation that we're typically exposed to. And it's interesting, the pie chart splits right down the middle. These blue areas all represent medical type of sources. So, you've got x-rays, nuclear medicine, fluoroscopy, different things like that. And so if you combine them all together, about half of this 6 is just coming from the medical industry and, our uses of that. And so that's a risk that we take, is being exposed to this radiation. But you can see that it's far and away above anything that would, actually make a person sick. The other half is natural sources. And the interesting thing about the natural sources is the bulk of this is from radon. Radon, accounts for, about 60%